Hi everyone, I'm audible. Okay, great. Give me one moment and we can start. Okay. Yeah, give me one moment. I think there is a little technical thing here. I'll just sort it out and then we can start. Hello, am I audible? Hello, am I audible now? Great, awesome. Yeah, screen is visible now. Okay, great. I think then we'll start finally. Uh, so welcome everyone, especially the new joiners who have joined us, I think today itself. So as I mentioned in the last class, like the introduction thing, that we'll be starting with recursion today. So let's start with that. Okay. So before we delve into the idea of recursion, does everyone here understand the concept of functions? Can you type in yes if you do, or no if you do not? Function is simply like just like maths, takes an input, gives out an output. Okay. May or may not give out an output. That's optional in computer science. So let's say, let's do some small output practice just so that you are like fully clear with the concepts, prerequisites basically. So let's say I have a main. By the way, every execution starts at main function, right? I hope everyone remembers this. Let's say I'm calling three functions here. Then I have a here, which simply does print a. I have b here, which simply prints b. And I have c here, which simply prints c. Quickly, can you tell the output? What will be the output? Everyone? It's a like literally seconds thing. Yeah. So first a will be called, it will print a. B will be called, it will print b. C will be called, it will print c. Okay. Important point to note here, things happen in sequence. It's not like a is called, b is also called, c is also called, and they will be at in random order. Is that clear to everyone? This is important for before going into recursion. Is that clear to everyone, that it will be sequentially? It will not be like all of them are called and they'll print in random order. Yes or no? Okay. So let me modify this a little bit and make it a little tricky. Now you help me out and find the answer. So here I will write, I'll call another b. And here I will call c. So my a function now looks like call b, print a. B functions look like print b, call c, and c is just print c. If this is the case, I think c is not visible. I'll just move it to the left. Simply print c, nothing more. Okay, just do a quick calculation. Okay, many people have. I hope no one got confused, but in case you did, I'll quickly tell how it works. So main comes, it says call A. We go to A says call B. We go to B, it prints B. First thing printed so far is B. Is everyone clear with the flow right now? Call A, call B, print B. Then call C. So we go here and print C. Then print A. Then we call B, which will simply print B, then call C, print C. So we have B, C. And finally, just call C, which prints C. Is everyone clear with this output? How it happens? Just take a look and let me know if this makes sense. Okay. Let's look back and see its internal implementation. How does the computer do it? So before that, anyone having any doubt here till now, please let me know with a quick doubt, and then I'll go back to it. Okay, cool. So let's look at the internal implementation. How does the computer do it? Okay, so computer has something called as a function stack, function call stack. Call stack is the common name for it. Okay, so how many of you know about this call stack? What is call stack? Okay, so call stack is a very simple thing. It simply stores the order of the functions which were called. So as an example, if we are at main and I call A, what this guy will do, it will store main here, telling us that, okay, main called this A in which you are right now. Am I making sense? Okay. Now when A calls B, it will again store A here, telling that, okay, you are in B, B was called by A, which was called by main. Is this making sense? What is the idea of call stack? So basically, it tracks your complete history of function calls, that these calls were made. Okay, let's look at the implementation further. Now B prints B, call C. What will happen? Can you quickly tell what will happen to the call stack when we call C? You can type in a quick answer. C will be called, right? Before that, what should I push here? Like basically, what should be added at the top? B, right? B is calling C, so B will be put here. Okay, let's go further. Print C and we say bracket close. Now, I hope everyone is aware of a word return, keyword return. What does it do? Can you quickly write what does it do in a single step? I know these are basics, but we'll try to quickly walk over them just in case anyone is not familiar. What does return do? Exits. Okay, so yeah, exactly. So exit is a wrong word. So what people think is return means everything will end. Everything will not end. Return simply means that I will move my control back to the previous function wherever it was left off. So when I return from somewhere, let's say I write return here, that means go back to your previous function and continue that. That will continue, right? If I had called C more times here, it will be called. It's not like return means I will exit from the complete thing. Am I making sense? Yes or no? It does not exits. It just gives the control back to its parent, the one that called it. Okay. In terms of computer, it simply means it will remove one thing from the stack, the top thing from the stack. That is, now it goes back here, right, where the C was called. And now we only have main A and B in our flow. We don't have C because it's gone, right? Am I making sense why this was removed? Because now the history is only main and A, not B. I am back at B. Yes or no? Is this making sense? Return simply means you have went back to the parent, to the previous one. Parent, by parent I mean the one that called it. And that simply means that you are removing one thing from the call stack. If you're not able to understand this, let me know with a no or a repeat. So return is going back to the caller, which in computer science terms means removing one thing from the stack. Call stack. Repeat. Okay, cool. I'll repeat it. So what was the stack maintaining? The stack was maintaining whatever functions were previously called, right? So for example, we started at main and we called A. So to maintain history, we said we'll put main inside the stack. Do you agree with this? Right? Yes or no, everyone who has written repeat. Okay. Now, A's variables are present at top. So after that, A calls for B. That means we put A here and go to B. Then B called C, we put B here and go to C. Do you agree? So at any time, my call stack is storing the past. Let's say I am at C, who called C, that is at the top. Then who called that guy, that is below it. Then who called that guy, that is below it. Am I making sense? Yes or no? Till here. What is the stack storing? Yes, no. Anyone with a doubt here? Then I'll come to return. Return is a simple thing to understand then, if you are clear with this much. Then I'm saying return is simply going back to the first caller. So who called C? B. So I'm going back to B and saying I'll run remaining code of that. In that particular case, I would say that my parents, like my callers, are only now A and main. B is no longer my caller. So I will remove it. Am I making sense? Because I am at B. I have went one step back. Am I making sense now? So it should store at the top who has called B. Who has called B? A has called B, right? Not B has called B. How stack is managed in tree-based recursions? That's, we'll come to that. Don't worry. Still, it's managed in the same way. This is a concept involved with function call. We're not even called to recursions, right? We'll see how it happens in recursion. But this is a simple function call mechanism, how it runs. Okay. Everyone, am I good till here? Like, in that case, C should be removed because remaining lines of B will run, right? So see, whichever you are running, you are at that position, right? You are actually executing that. What you want to store is the history. That is, when you go back, where do you have to go back? Am I making sense? Yes. So when you are running B, you have to go back to A, not B. So you have removed B. Am I making sense? Yes or no? If you want, you can add another layer. Like if that makes easier to understand, you for yourself can add another layer. But basically the point being, it just removes one entry from it so that it can store which to go back to, and it does not just completely exits everything. Is that clear to everyone? That how this function execution happens? Yes, no? Others? Any doubt? Let me know. Okay, cool. So let's now introduce function. If this much is clear, we can go ahead and introduce recursion. So let me introduce recursion to you all. So I'll introduce with the real life example. Let's say you have to calculate factorial of big number, right? Let's say I want to calculate factorial of 100. Can I say it will take a lot of time? Yes or no? Okay. Now let's say you have some good friends with you and you tell one of your friend that please calculate factorial 99 for me. And what I would do is I would simply multiply my 100 to it. And that would be my 100 factorial. Could you please brief it once? So factorial. Are you telling me to tell you what factorial is? So factorial is simple. So when we say 10 factorial, we are calculating 10 into 9 into 8 up to 1. Everyone knows this, right? What is factorial? Factorial of n. N into n minus 1, n minus 2, n minus 3 up to 1, right? That is what factorial of 10 or factorial of any n is. Okay. So assuming that you know this, let's say you want to calculate factorial 100 before recursion. Did you miss it or are you having doubt in it? Because that was a long discussion. Continue or missed a lot? No. So still we are introducing recursion, so don't worry about it. So if you have missed it, that's okay. You can just go back and rewatch in the recording, right? It will solidify your understanding a little bit more, right? And in the meanwhile, if I get some time in the middle, I'll be able to explain it again. Okay, cool. So as I was saying, let's say you want to calculate 100 factorial, which is a huge number. You are like, I can't do it alone. So you have some good friends. You tell one of your friend, calculate factorial 99. Okay. Let's say he calculates factorial 99. Can I say I just need to multiply 100 to it to get my answer? Yes or no? Right? So this is being calculated by your friend. Okay. Now your friend is just like you. He will say, I'll give factorial of 98 to another friend and multiply 99 by it. Okay. And all the friends are similar in fashion. They say, I'll give 97 to another and multiply 98 with it. Am I making sense? Yes or no? So this is exactly what happens in recursion. In recursion, you say you have a huge task that you want to do. What you do is you do small part of it and give the remaining task to a clone of yourself. Okay, your friend becomes your clone in a way. So you give the remaining task to a clone of yourself and that guy will solve the remaining tasks. Am I making sense? That is the basis of recursion. That is, you have to solve a huge task, you break it down, give those smaller tasks to your clones to solve and combine their results to get your own answer. Yes or no? That is the simplest idea of recursion. We'll come to code. That's not a worry. That's a simple thing. But am I making sense first what recursion is? What is the basic idea of recursion? Yes or no? Okay. Others, anyone who does not, just type in a no. Okay. So let's see how this will work in case we want to write it in the form of code. So what did I say? I said that let's say you want to calculate factorial of some n. So what will be the return type of this function? What should it return? An integer or a long, right? Whichever depends upon your language. So let's say I want to calculate int factorial of n. What did I say? I said I'll give a smaller value, which is n minus 1 to a friend of mine, which is actually a clone. So I will say, okay, my clone, what is clone? Fact only. Calculate factorial of n minus 1. And then what I will do is, I will simply multiply it with n and return that. Do you understand what 3 steps we are doing here? Just like we did here. I said to my friend, you calculate first a smaller factorial. That is what I told my clone. You calculate a smaller factorial, give me the answer of it. I will multiply it with n and return it back. Yes or no? Is this making sense to everyone? Others? Yes, no, repeat. A very simple example, right? But from the fundamentals. Okay. And from the main, what I will do is, I will say print factorial of whatever I wanted to, let's say 100. Okay. So it's 100 is called. Let's see how it will execute. Again, keep in mind your stack diagram, right? So we'll try to build the stack with it also. Let me take a smaller value. Let's say I'm just calculating factorial of 4. So what will happen? Main calls factorial of 4. So if I have my stack, my main is pushed here, and I have called factorial of 4, right? Everyone? Factorial of 4. Then I'm saying calculate and call factorial of 4 minus 1, which is what? 3. So call factorial of 3. So the factorial of 4 has called factorial of 3. So in a way, factorial of 4 is pushed here. Is this making sense? Why factorial of 4 was pushed here? Because factorial of 4 called factorial of 3. So we have moved on. We have passed the control to our clone. And this thing has been pushed here because that was called by factorial of 4. Then again, factorial of 3 here. It calls factorial of 2. Then again, factorial of 1. And it will go on factorial of 0, factorial of minus 1. How to stop it? Can you see that? It will go on, go on, go on. Okay. Let's do 3, 2, 1, 0, minus 1. But it will go on. How to stop it? You need to stop it, right? Exactly. So as soon as we have reached factorial 1, we directly know the answer. We directly know the answer is 1. Or if you want to stop it even before, for 2 also, you directly know the answer is 2. So you can write that here before passing it on to the friend, that if I just want to know factorial of 1, simply return 1. This special statement is called your termination condition. And this is very, very important, because if you miss this, your recursion will go into infinite. And believe me, whenever you code recursion, this will happen a lot, that it will say TLE, it will say infinite recursion. If it ever says infinite recursion, that means in some case or the other, there is no termination condition and it is just continuing to go on. Am I making sense with this? Why do we need to write this condition? So it's like if a clone gets factorial of 1, he'll not call his another clone. He'll simply say answer is 1, just take it. Right? So that is exactly what we are doing here. Others, is this making sense? Everyone, just type in a quick yes. Then we'll move on. Okay. So Basically, we stop here. Factorial of 2 called factorial of 1. Factorial of 1 simply returned 1. Now, return comes. That means one thing is removed from here and we'll start where we left off. So what does value of x now is in factorial of 2? It is 1, right? So now what it will do? It will do 1 into equal to 2, which is 2, and return that 2. It will go back to factorial 3, which will say 2 into 3 is 6, and it will return 6, and so on. It will continue. Is everyone able to visualize how this is happening? Yes or no? So if you ever want to imagine it, it's like a chain. You telling your friend, that telling that, that telling that, and those last guy will tell you 1 is the answer. Then you will multiply, 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 and it will come back to you. Is this thought becoming clear in the mind? This is important so that you don't confuse later on as to what is happening. Because next step, it is going to get 10 times more confusing at least. So till now, if you have any doubts, please ask. Okay, cool. I think everything is clear then to everyone. Okay. Now I'll give you how is it better than looping. We'll come to that. We'll come to that. Don't worry. I have almost all the questions answered from you beforehand. If you get anything, just write it down. If it's not a conceptual thing which I've covered so far, right? Yeah, we can also write anything. Yeah, you can combine it. This seems very much easier to understand that there are 3 steps. If you want to combine it, you can do that. You can simply write return n into factorial n minus 1. This also works, combining all 3 into a single step, right? Right, I can even make it one step, like return if n equal to 1, then 1, otherwise n into factorial n minus 1. But now this gets confusing, right? This is not very clear to understand compared to that. Okay, moving on. So I'll give you one piece of code. Try to get the output for it, basically, right? So let's say there is a function f which takes int I. Okay, what I'm doing is I'm printing I. First of all, if I has become greater than or equal to 3, I simply return. Then I'll call f of I plus 1, and I'll call f of I plus 2. Okay, this is a small piece of code. Okay, just try to write it down on a piece of paper, try to evaluate it, use stack diagram if you want, but try to get an answer for this. And from main, I am calling f of 0. Okay, it will get confusing, so don't worry, but just try to see if you can endure the confusing nature of it. Zero, 1, 2, 3, 4, 3, 2, 3, 4. Okay, maybe right. I'll also have to calculate. Others? Okay, everyone is, I think, getting the same. 2 people are getting the same actually. If you guys have like gone through the recursion video, then this is a little bit of cheating, but yeah. Others, did you try it out? 0, 1, 2, 3, 4, 3, 2, 3, 4. Okay, everyone is getting, I think, the same. Okay. Great, great. If you are able to get that. How many of you got confused? Can I get a yes there? I know some people must have. Like, it's not very simple, right? People got confused, right? Okay. Others, yeah, many people got confused. Right. It's confusing. Like doing this via stack is very, very difficult, right? So I would advise not to go for stack. So there is a second mechanism that I'll talk about, which is using a recursion tree, right? And we'll try to draw the recursion tree and then see what we are doing. Okay. Let me move this. So we'll discuss about recursion tree diagram. Okay. So first we are calling f of 0, right? Let's see what all f of 0 is doing. F of 0 is basically doing three things: printing 0, calling f of 1, calling f of 2. Can I say that? Yes or no? Everyone with me? This check will not be passed, right? So basically it will do 1, 2, 3, three things, right? So what you guys would have done while drawing stack diagram is you would have gone to this, but there is no way of knowing that you will come back to this and you have to do this. Yes or no? That is a problem that happens with stack diagram, that if you go on to this path, you can't remember what all you have to do other, like at the other step. Okay. So for that purpose, when there are multiple recursive calls, tree diagrams works best. So what you do is you write all the steps as form of a tree. Okay. How many of you know what a tree is? Yes, no? Anyone who does not know what a tree is? No need to worry. It's a simple, very simple thing. Tree is basically some structure like this. Basically what you do, this is called parent has certain children, then those also have certain children, and those also have certain children, and so on. So it's a structure which starts somewhere and branches out below. So if I want to make an array or a linked list, I will say this: it starts and go in a linear fashion, but tree starts and goes into different branches. Is this okay? So this kind of a structure is basically called a tree. Okay. So what you will do is you will say I called f of 0, which has three branches that it needs to do. It needs to print 0, then it needs to call f of 1, then it needs to call f of 2. Is that making sense? Yes or no? This is making sense. F of 0 needs to do three things: print, call this, call this. Okay. Now remember, things happen sequentially. So what it means by sequentially, first this will happen, then this complete thing will happen, then this complete thing will happen. Now we'll see. Then it calls f of 1. So let's see what f of 1 does. F of 1 prints 1, calls f of 2, calls f of 3. So print 1, call f of 2, call f of 3. Do you agree? And let's continue. Let's make the complete tree. Then f of 2, what it will do? Print 2, call f of 3, call f of 4. So print 2, call f of 3, call f of 4. Okay, what will this f of 3 do? What are the steps that f of 3 will do? Right, print and return. So it just has one step, print, and then it will return, right? So it will only do print 3. This will only also do print 4. This will only also do print 3. This one, print 2, call f of 3, call f of 4. This one just prints 3. This one also just prints 4. Is the whole tree clear? Yes, no, repeat. Just try to wrap your head around this and see if this makes sense. Okay. So you draw this tree. Okay. This completely mentions the whole setup that will happen. So how will the printing happen? What is the order of execution? Order of execution is first you go to first branch, complete it, then go to the second branch, complete it, then go to the third branch and complete it. So first we'll go to the first branch and complete it. So completing it means printing 0. Then you go to first branch and complete it. So complete it means this whole thing will run before you go into this. Am I making sense? Yes or no? Because once we call f of 1, this flow is started. It has started running. It will run this, it will run this, it will run this. Only then it will return back to the parent to let it call f of 2. Yes or no? Is this making sense? Yeah, depth. Let's not introduce depth first right now, but idea is same. Is this making sense, everyone? No? Repeat if it is not. Okay. So then we can say f of 1 is called, so print 1. So 1 is printed. Then it calls f of 2. So this complete thing will run before we go here. This guy will print 2. Call this print 3. Call this print 4. Then this will call 3. Then this part print 2, print 3, print 4. So in a way, we are evaluating the bottommost nodes from left to right. Can you all see that? Yes or no? So if there are multiple recursions, best way to visualize is using this tree, because you'll be able to clearly see that, okay, first this complete thing will happen, then only I'll move on to the other branch. That is much more cleaner here than in stack diagram. Is this much clear to everyone? Yes or no? There was a question, can we solve this problem quickly without creating tree on paper pen? Solving problem via recursion tree on paper pen took at least 3 minutes. It did, but you have to do that. There is no other way. If there are output problems, then they will have smaller values, which you can actually draw on paper. Okay. Otherwise, there will be a pattern. Like this thing did not have any pattern. Otherwise, there will be a pattern. Okay. No, you can't. No, you can't. Don't try. At least not in the beginning. Later on, if you like have that kind of thought process, maybe you can try out. But don't try it in the beginning, at least. Okay. Let's move on from this. Is everyone clear with this much? Let me know with a yes, then we can move on. Okay, one more important concept that we need to cover here before we move on to problems is how pass by value and pass by reference changes things. Okay, everyone understands what's the difference between pass by value and pass by reference? Yes, no? Okay, some people are saying yes, some people are saying no. I don't see any no. Did anyone say no? Can you type it again? so that I can repeat it. Anyways, it's a very small concept. When you call a function and you pass a variable into it, when you pass by value, it creates a copy. In this case, there is a copy created. But when you pass by reference, same variable is used throughout. You may as well declare it global. Do you understand global? What is a global variable? So a global variable can be accessed by everyone, right? And they can simply modify it. So whatever modification happen, it's at the top level. So same thing is here. When you pass by value, it's by copy. When you pass by reference, it's by it's same variable which runs throughout the code. Okay, let's see the implication of it. So let's say I write some function like this. Okay, so this is passed by value for now, and I say that let's say x plus plus func of x, and if x is greater than or equal to 2, return, and here you do print x, and let's say I call func of 0. Okay, help me out. What will happen? Can you try to draw a conclusion of it? You should be good into output questions by now. So just try this out and see what happens. What do you think will happen? What will be printed out? Two, 1, 1, 0. Okay. Others, take your time, but try to see what prints here. This part is important, yaar. Matlab, if this part fails, so it will be difficult. It runs infinitely. No. Why will it run infinitely? X will become greater than or equal to 2, right? So it will not probably run infinitely. So let's see what happens. Okay. So main calls function of 0. Right, let's draw our stack because there is only one, so let's do it with stack. So what happens? This is f of 0. It does 0 plus plus, it becomes 1, and it calls f of 1. So there was f of 0 which had x equal to 1, and it called f of 1. Do you all agree to this? F of 0 will do 0 plus plus, which will become 1. It will call f of 1, right? Everyone? Yes or no? Okay, it will go here. Then f of 1, what will it do? It will check this. It's not true. It will do 1 plus plus, that is, it becomes 2. Then it will call f of 2. So f of 1 called f of 2, but f of 1 had x equal to 2. That is why it called f of 2. Then what will f of 2 do? X is greater than or equal to 2, it will return. Do you agree with this much? This is how the flow will be. When it returns here, it will simply print whatever the x was, that is 2, and return from there as well. This guy will also print the x and return from there. Do you all agree? It will be 2, 1. As the output. Please repeat. Sure, I'll repeat it. We called f of 0. What did 0 do? It did plus plus. It became 1. Right? It became 1. Then it called f of 1 and later on printed 1. Do you agree? So it is doing 2 steps basically. If you want to do it with tree, it is basically doing 2 steps. X becomes 1, it calls f of 1 and it prints 1. Do you agree? Yes, this is recursion. Then this guy f of 1, what it does, it checks this, it makes it 2, calls f of 2, prints 2. So call f of 2, print 2. And this f of 2 will simply return. So basically we'll print 2 and we'll print 1. Are you clear with this now, with the tree diagram? Okay. So here we had passed x by value. What happens when I pass x by value? Each function had their own copy. So when f of 1's x was different from f of 2's x or f of 0's x. Are you all clear with this? Just go with recursion always. I think, sorry, tree always. Tree seems okay. Right? Yeah. Could explain with respect to Java. So see, in Java also, concept is same. Either is pass by value, pass by reference. There are different ways or syntactical ways to actually make them pass by values or pass by reference. Okay. In Java, mostly huge structures like list or strings, they work like by value. But structures like your normal integers, they work by sorry, lists etc. work by reference, whereas integers etc. works via value. But that's a specific choice. You can modify it to work in your own way. Okay, so you can read about it, and if you want, I'll pass on the material as well. Cool. Yeah, so they have given it a special name, but essentially it works like pass by reference, right? For lists and strings and stuff like that. Anyways, moving on. I'll pass you on, like I'll post both materials for Python and Java if you want to check it out, and how to pass by reference or pass by values for different stuff. Okay, cool. So is 2-1 clear to everyone? Just type in a yes. Why F2 do not print 2? Because when we go to F2, it is if x is greater than equal to 2. So it's already there. I simply return. So it never reaches print. Can you see that? Why it never reaches print? Someone had asked this, right? Okay. Let's change this variable and let's say it is passed by reference now. So what do you mean by pass by reference? You can assume your x is global. So whatever you modify, it modifies here. So let's see how it happens. I call f of 0, so x becomes 0. I do x plus plus, this becomes 1. Do you all agree with this much? Yes or no? F of 0, as it is a global thing, plus plus, it becomes 1. Then you call f of 1. So same idea, you call f of 1, but this time you will write print x, not print 1, because you don't know when it returns here what will be the value of x. Can you all see the subtle difference? Yes or no? Because it is global, right? Earlier it was not global. Earlier it was my own x. So as there is no statement in the middle, I can be sure that this x will remain 1. Yes or no? Are you all able to understand this idea? As there was no like other statement in the middle, this x which was 1 will remain 1. So I wrote f of 1 and print 1. Repeat once. Sure, I'll repeat it. Okay. So what I'm saying is, do you understand first the difference between pass by value and pass by reference? In pass by value, your variables are your own, right? No one else can modify them. Are you able to first get this? In pass by value, your variables can't be modified by other functions. Why? Because when you pass it on, they make their own copy and they work with that copy. First, is that clear? Yes or no? Everyone, is this statement clear? That they are your own copy, no one else can modify it, right? So when this was passed by value, what did I say? I said f of 0 will call f of 1 and print 1. Did you understand that? There were just two steps: call f of 1, print 1. Yes or no? And that is how we wrote the tree. First, is this much clear with the pass by value? Yes or no? Then we'll see the difference. So what happens with pass by reference is that your variables are exposed, right? So if anyone modifies x, they are essentially modifying your x also. Okay, so your variables can be modified by others. Yes or no? So what I'm saying is, I called this f of 1, which might change the value of x before printing. So I can't write print 1 here. I will write just print x. So whatever is the value of x, once this thing completes, that is what I will print here. Is this making sense? Yes or no? So now it's no longer my particular variable x, right? It's like the variable x which is there globally. So anyone can modify it. Like I called this function might modify it in the meanwhile, and then I will print that value, not 1. Okay, so let's see how it happens. So f of 1 is called. What will f of 1 do? Let me just clean this up a little bit. What did I write? F of first x plus plus f of x and print x, right? And let's say this is now passed by reference. So what I was saying is, this can be treated like a global variable x which had value 0 because I called f of 0. Now f of 0, what it did was, it increased it by 1, made this 1, called f of 1 and said print x after completing f of 1. So it called f of 1 and kept here print x after completing f of 1. Okay, then f of 1, what it does, again it checks this, it increases x by another 1. So it will say plus plus, this becomes 2 now, and it calls f of 2 and then again says print whatever value is of x. Is this much clear? So I've only modified print 1, print 2 with print x because they are now all going to print the same thing that is there globally. Yes or no? I'll take up all the questions. First, please understand this completely, then ask your questions, right? Don't do that. Okay. Everyone else, this is the only thing that is modified because they are the same x. Yes or no? Yes, so that is why no. How can they change before fx? That is the first statement that I'm calling, right? I'll repeat what I just said. F of 0 is called, it checks this, it does not return, it does plus plus, it becomes 1, then it calls f of 1, right? Now, when we call this f of 1, it might have modified my x. So by the time I reach this print statement, my value of x might be something apart from 1. That is the whole idea. Is this making sense? Yes or no? Okay, so what will be the output? What do you think? Right. So this guy will also print final value of x, which is 2, and this guy will also print final value of x, which is 2. So output will be 2, 2. Does this make sense? Why the answer will be 2, 2 and not 2, 1 this time? Okay. Now you can shoot your questions if you want. If you have understood this logic or not, if you want me to repeat any part of it, I'll do that. Please explain this output again. Sure, I'll do it. So did you understand the difference? In value, everyone has their own copy. In reference, it's just one copy. Okay, it's just one variable. They are all modifying. So first I called f of 0, making x as 0. Then this f of 0 increased it by 1, made it 1, and called f of 1. So this first step was called f of 1. Is that clear? That much? Now I can't directly say it will print 1 after calling f of 1 because f of 1 might modify this x in its own run. Is that okay? Because order of execution is important. This will completely run, then only I will print. Right? So I can't just say value will be 1. So f of 1 calls, it does plus plus. So this becomes 2 now. It calls f of 2. And again, I will print once I return from f of 2. So f of 2 is called. F of 2 simply returns. So final value of x after all the recursions is 2. And that is what is being printed by both the functions. So the answer is 2, 2. If you want to understand via tree, it's like f of 0 is doing 2 steps, calling f of 1 and printing x after this call is complete, whatever is the final value of x. Then f of 1 will again do plus plus, make it x2, call f of 2, and then print the final value of x after f of 2 is complete. Now f of 2 simply returns. So final value after this much call of x is 2. So both these guys will print 2, 2. Is that clear now? Why the output is 2, 2? Yes or no? Great. Okay, other people had some doubts. You can post those doubts here if you have. What will be the output of the same if I move print x one step up? Do that. What do you think? What do you think the answer will be? Everyone, can you try that? Move, swap print x and fx. What will be the output? Yeah, that is a simple case, right? That will first print, then call f of 2. So 1 will be printed and then f of 2 will be called. Then that will again print 2, then call f of so on, right? Not 1, 2 actually. Not 1, 2. 1, 2 is wrong. Can you all correct it? 1, 2 is the wrong output for this. Oh, actually 1, 2 is right. Sorry. X plus plus is before. My bad. So I was moving this even before this. So then it would have been 0, 1, but that's okay. Sir, if the same variable of x is decreased in main function and called in func of x, I don't get it. What do you mean to say? Like maybe you can put a code snippet. What do you want to do? Okay, you are saying if I declare x here, are you saying that? Then there is a conflict, right? 1x is being passed and 1x is being declared. So which one to choose? Generally, the more specific one is modified. We can't directly pass 0 in f if it's passed by reference. Yeah. So I am assuming x equal to 0 and then pass x. That's okay. That's a small syntactical thing. But I was giving the idea how the output changes with pass by value versus pass by reference. Local one, right? Yeah. So local one is preferred over the global one. If you are ever using X, first it looks in local setup, then it goes beyond to look for your variable. Okay, cool. So now we have covered all the theory portions of recursion. How the code works with call stack. It will be very difficult to do that, to be honest. But the idea will remain same. This time, X won't be here. As it's a pass by reference, it will be in some other space, probably with main. And everything will be modified in this only. That will be the only change. But it's very difficult to explain it via the call stack. Okay. Prefer this, I would say. Prefer this unless there is a specific need for it. Cool. Let's quickly, but let's do one more thing quickly. How to differentiate if the code is passed by value or passed by reference. Every language has a specific syntax. As an example, in C++, if you write int x, it's passed by value, whereas if you write int and x, it's passed by reference. Okay. So I'll come to that. When to choose pass by value, when to choose pass by reference. So do you guys see any downsides of pass by value? Any downsides you see of pass by value? Space, right? Multiple copies. Great. So right now you were having only a variable that you were passing, right? But let's say it's a huge list. So if this is a huge list that you are passing by value through different functions, each of them will make their own copy, right? So if there are n functions that are called one by one, all of them will have a list and it will be n square time complexity. Yes or no? If the size of the list is n and there are n functions being called, all of them will have size n, so total will be n square, right? Yes or no? So space is adversely affected in case of pass by value. So problem with pass by value is that space is more. Problem with pass by reference is that the code becomes complicated to understand. And you have to be very careful that the same variable might be modified by something else and it might impact your like whole output a lot, right? As an example, this function itself seemed like a very simple thing that will print 2 1, but it ended up printing 2 2 just because the variable was passed by value, right? So like writing setup can become complicated if multiple functions are able to edit that same variable. Okay, is everyone clear with this? But we do have some rules with pass by reference that helps us. Specific one being do undo rule in backtracking. We'll cover that. We'll cover that probably in the next class itself. So that rule will help in making things much more simpler. In JavaScript, the pass by value and reference is resolved with using let and variable. I'll have to honestly check for JavaScript. You can check it out, which works. But I think let and var do not do anything with that. That is a separate issue with like global context and stuff. That has nothing to do with this. Okay, cool. For the remaining time portion, what we will do is we'll take up 1 or 2 problems that we can solve via recursion. And what you guys can do is you can try to write a small code for this and see if you are able to do it. No worries if you were not able to wrap your head around the complete thing. You can take more time with it. There are videos on the dashboard. You can go through them one by one and see if you're able to understand this again, right? So let's quickly do one problem. So the problem says, let's say you are given a number n, which could be a little huge. As an example, let's take 999. What you need to do is you need to find sum of its digits repeatedly. So as an example, I'll take all that, Satish. Right now, we have not taken really any question that can only be solved via recursion, right? and we'll see those questions that can only be solved by recursion. Okay, so as I was saying, you have a number n like this. What you need to do is repeatedly sum its digits. So if I sum its digits up, I get what? 27. Then if I sum that digits, I get 9 till the time you get a single number. I'll take one more example. Let's say I take this. So when you do 1 plus 0 plus 0 plus 9, you get 10. Then you do 1 plus 0 and you get 1. So you want to simplify a number by repeatedly taking sum of its digits. Is the question clear to everyone? Number can be huge. It can be up to 10 to the power 18. You can imagine. But yeah, this is the question. Is everyone clear with the question? Yes, no. Okay, so generally in recursion, what we think about are three things. First, termination. When do you want to stop your recursion? Second, propagation. How do you make sure that you pass on a similar setup to your neighboring function or your friend? Third is how to use that calculation and find the answer, right? So let's try to think about all these three one by one. First, let's think about termination because that's generally the easiest. Which friend do you think will directly return you the answer without doing much? Which number do you imagine yourself? Which number, if you get and you are asked, try to find sum of digits, you directly will be able to tell the answer in a way, right? Some of you are writing it, right? So if the number is less than 10, that is the number is 1, 2, 3 up to 9, answer is simply n itself. Yes or no? Single digit numbers. Everyone? Are you okay with this? So our termination becomes simple. If n is less than 10, simply return n. Does that make sense? Yeah, so I'll assume n is positive. Any which way is negative will be difficult, right? Okay. Think next, what should be the preparation that you should do before passing to the friend, or how do you and your friend communicate? What to do? Any ideas? Like factorial case was simple. I said you would calculate factorial 99, I'll multiply 100 to it. Here what to do? Right. So here I will do the pre-work, right? Here I will do the pre-work. I'll say, okay, I have 999. I'll submit digits up. And then the next problem that I get, I will pass on to you. So I will do this first step, calculate 27 and pass you on 27. Am I making sense? Yes or no? Slightly different. In factorial, I was saying you first calculate, then I'll multiply your answer with mine, right? Here I'm saying I'll first do pre-work, then pass you on a function. Okay, cool. So let's do that. How to calculate this? How to calculate sum of the digits? How many of you know how to do this? Calculating sum of the digits of a number. Right, using mod and divide, right? So simple idea. Let's say my sum is 0. I'll say while sum is greater than equal to 10. Sorry, while number is greater than equal to 10, what you do? S plus equal to n modulo 10, and you do n divided by equal to 10. Right? Keep on dividing it till you get a numbers greater than, till you have a number greater than equal to 10, and finally add your last number. Or you can even run it till 0 and keep on dividing. Does this make sense? Yes or no? Yeah, Python guys have more easier things, but yeah, this is the main setup. Till you are getting a greater than 10 number, add its modulo here, divide, keep on doing it till you get a single digit, and then just add it up. Okay, now you have your s. What do you do? Let's say you have this all is written in a function int f int n. You just call f of s and return whatever value you get from there. So whatever your friend gives you, that is your answer, and that you return back. Yeah, I'll come to that. But is the whole setup making sense? Yes or no? 3 steps. Termination, calculate the next sum, and you ask your friend to calculate it and return whatever your friend has given. Okay, someone was saying below portion is not visible. Is it? Is this part not visible? I can see it's visible in my screen. Maybe you have zoomed it or something. I'll write it here if you want. So I have just written 2 statements here. Like after we have done this while loop, I'll write s plus equal to n to add that single digit. And then I have written return whatever your friend tells you the answer is. So you do one step, that is calculate the sum, give that number to your friend, whatever your friend gives you back, that is your answer, and you return it. Does that make sense? That is what was happening, right? Like if your friend is calculating for 27, he'll arrive at 9 and give you back that 9. So your answer is also 9. Okay, cool. So that was one question. Someone was saying, what if sum of digits does not lie within the limit? Tell me one thing. If the number is up to 10 to the power 18, how many digits can it have? If the number is up to 10 to the power 18, what do you think? How many maximum digits it can have? 18 digits? What maximum sum can we get if there are just 18 digits? Yeah, 18 into 9, right? Which is not such a huge number. So it will never happen that sum does not come inside an int. 18 into the int is very, very small. Can you see that? This might have to be long, that I agree. First step, but later on it's just int. Yeah, if n is very big, then we can put it in long. If n is even more than this, then you'll have to store it in a string and work with it for one step. I'll put such a question in the group. So number will be huge. So you have to do one step in a string, like, and then move on to this particular code. Great. This was a simpler question. Please explain s plus equal to n line. Sure. So do you understand what this is trying to do? So we are trying to divide by 10 to remove the last digit till we get only one digit left. Yes or no? So for example, if it is 9, what it will do, it is greater than equal to 10. It will add 9 to the answer and divide by 10. Dividing by 10 gives 9. It will stop as soon as my number becomes smaller than 10. That is, it will stop at 9. So this last digit would not have been added. That is what I'm doing here by adding it. Is that okay? If you don't want to do that, you can simply write here n greater than equal to 0 till everything is taken, right? So in that case, you don't need to write this. Is that fine? Yeah. Cool. So this was a relatively simpler question. I'll take a slightly tougher question and you guys can try it out in the remaining time, as well as take it up as a homework. So in the next class that is upcoming, like tomorrow's class, we'll take up a little tougher problems on this. Okay. So make sure you spend some time with recursion today and try that out. Okay. So yeah, this is also slightly a tougher problem. It's called pyramid of glass. So it says there is a setup like this. There is a glass here. Then there are two glasses like this. Then there are 3 glasses like this below it, then 4 here. This kind of setup for n rows. So n rows of glasses like this. Now what happens is we are pouring x liters of water here, and each glass has a capacity of a single liter. Okay, so it's a pyramid of glass. Every glass has a capacity of a single liter, and we are pouring x liter water here. Okay, so let's say x is 5. What will happen? 1 liter will fill here. Do you agree? That is what will happen. 1 liter, it will fill. Remaining 4 liter, what will happen? Overflows on both sides equally. So 2 liter goes here, 2 liter goes here. Does that make sense? How the setup is? Okay. Same thing will happen with these guys. So we are pouring 2 liter here. 1 liter will fill. We have 1 liter remaining. Half liter goes here. Half liter goes here. Similarly here, 1 liter fills. Half goes here. Half goes here. So this will be half. This will be full because half plus half is 1. And this will be half. So you have to tell at the end of this setup how many glasses are full. Okay, so I had 1 glass full, 2, 3, 4. 4 glasses are full here. So your x will be variable, your rows will be variable, and you have to tell with n and x how many glasses will be full at the end of this whole thing that happens. Is the question clear to everyone? So n rows of pyramid glass, we are pouring x liter from the top, whatever fills, remaining overflows on both sides, and you have to calculate how many glasses are full at the end of this whole thing. Okay. Yes, exactly. So you have to take it like a 2D grid and simulate the process, right? But I'll give you all time. So think about this question, discuss it on the groups if you are able to solve it. I'll post the question link as well. I'll post this one also and this one, both of them. And we'll give you some more questions to practice, right? So I'll post all that on group. Tomorrow we'll do some tougher stuff on recursion and backtracking. So make sure that you have revised everything learned so far. That is the first step. Okay. Cool. Any questions so far? Please ask. I'm still here for 5-7 more minutes. So otherwise, let's see you tomorrow. I think it was a like difficult session. Is there any greedy way to solve the previous problem? This one or this one? When to use call stack and recursion tree? So my personal choice is when there is a single call of recursion, let's say factorial 10 calling factorial 9 calling factorial 8, then I go for stack because it seems easier. Just put your stuff there and you are able to calculate. But as soon as there are more function calls, like one is calling 3 times f of I plus 1, f of I plus 2, f of I plus 3, then that becomes too difficult to handle in call stack. So I go for recursion tree there. But that's a personal choice. Some people find it more comfortable to always go for recursion tree. So it's up to you, right? But I would say at least if there are more than one calls, don't go for stack. That will never work out. Okay, there was one more question. How to identify whether a question can be solved by recursion or not? Okay, so till now, whatever questions we have discussed, including this one, they all do not require recursion, right? I can do them with the help of plain iteration. This can also be done via plain iteration. Yes or no? I'll write another while loop here. While n is less than equal to n, you keep on doing this stuff. Okay, so till now we have not really experienced any question which is only solvable via recursion, but we'll discuss that. We'll start the next class from that only, like recursion versus iteration, when to choose which, and we'll take some problems which are only solvable via recursion, okay, or some complicated logic apart from recursion. I think if the number is bigger than solving using tree is time taking. If the number is bigger, then the output question will not be there, or there will be a set pattern. So if you solve it for small numbers, you'll be able to see how it is happening, right? And simulate that to big numbers. So as an example, if I pass f of 10 to the power 5 into this function, then and I solve it by f of 3, whatever the output is, that will indicate how it will work for f of 10 to the power 5 also. Okay, I'll post all that, Sujay. I'll post all that on the group, that which are the things that you should cover. So that I'll post, don't worry. Means I have to find pattern. If it's a huge question, then pattern would be easier to spot. That's what I'm saying. Like the question that I took, where we had f of I plus 1, f of I plus 2, that was not that clear. Like the pattern was not that clear there. But if the question would have been something else, the pattern might be much more cleaner. So as an example, I will give you one, right? Let's say I'm having f of x. I'll say f of x plus 1, print x, f of x plus 1. X is greater than or equal to, let's say, 10 to the power 5, return. Okay, this seems like a huge thing, but if you even solve it for, let's say, up to 3, you'll see the pattern that first I'm calling f of it, printing x, and then f of. So if you do it for small numbers like 1, 2, 3, you'll be able to see how it works for even 10 to the power 5. Is that okay? Can you try this out? Just note this down and try it out on yourself. Provide some set of questions to better the understanding and problem solving. Yes, in the groups I'll be providing those, and you can take it up from there. Okay. Cool then. I'll stop here then. Anyone else? Any questions? Please let me know. Let me unmute. Oh, okay.
Hi everybody, Anup here. How are you? Some of you might have already started feeling it is too difficult for them. So I just wanted to tell those who are finding it difficult. How many of you are finding it difficult already? Anybody who is finding it difficult? Okay. So with no time, you will start finding it difficult. So basically, what happens usually, what I have seen in past, what I, Bharat and Vivek have observed in past is that there will be a sharp decline after 4 or 5 days. Why am I saying that? Because you should not be the one who should be giving it up. So just make sure that, after 3 or 4 days, you feel like it is just too much. Let me get over it, or let me drop it, or it is just too much. So you might find it difficult in the beginning. You might take some time to assimilate it. I myself have been sitting in somewhere like over 100 workshops in last 5 years. I have never been able to understand it. So it is difficult. The content that we'll teach as we go further will be even more difficult. But what we have seen consistently is that those who keep practicing, they go a long way. Matlab, if you'll not give up, if you'll do your homeworks nicely, if you'll put your self-effort, you'll go a long way. You might not understand it on the day it is taught, but maybe after 15 days of practice, you'll understand it, but you'll understand it. So just don't give up. So today's rule for all of you is, even if you don't understand a bit, even if you find difficult, do your homework, whatever is there on Renaissance dashboard, cover it up from there, and do like give your 100%, and don't just give up because you feel like, oh, it's just too much. Is that fine? Because a lot of us will feel it is too much in 4 or 5 days, you know. So just don't give up, because in long term you'll be able to do it. Even if you're not able to do it today, you'll be able to do it 15 days later, 1 month later, 6 months later. Sometime you'll be able to do it. Okay. So just like hold on, don't jump out of the wagon, don't jump out of the workshop, don't jump out of the wagon. Just hold on. Okay. Whenever you find it is difficult, hold on. Okay. Everybody is happy. Any issues anybody is facing? Yesterday we had a small glitch in video players because of a lot of load. Like a lot of people were playing probably at the same point of time. Anybody is facing any other issues, you can just write in the chat, and then we can wrap it up. Cool, then have a great day. If you find anything that is bugging you or anything that is bothering you, just let us know. Be happy. Have a great day. We are referring people for Rippling and Tower research. If anybody feels that much prepared, they can let us know. Of course, you should have already graduated from the college if you want to apply. Where do I find yesterday's lecture? You'll get its link on the group. We'll send it again if you have joined today. Okay. Bye-bye.